This question asks us to write the equation of the total scatter factor, define setup, what is its purpose, and then to show the relationship between total scatter and the field size. So right here we have our total scatter factor. This is very important to get accurate dosimetry, especially for not only our machine but our treatment planning system. So really this is the dose rate at a reference depth for a field size, and that is going to be divided by the dose rate at the same exact point in depth as a reference field size. So really everything is the same. It's the dose rate at the same exact point, but the numerator is going to have whatever field size that isn't your reference field size. Now, this obviously can vary. A lot of people use 10 by 10, right? That's the most common reference field size. That's what all the clinics I've been in, that's what they are. So I would say reference field size is 10 by 10, and this numerator is the same point for any other field size, all right? And we are wanting to do 100 SAD, and our reference depth in water. And this one actually can vary a little bit in what you want your reference depth to be. Could be 10 cm, whatever you choose. So the equation specifically for this is SC times SP equals SCP. Now SCP is the total scatter factor. The SC is the in-air output factor, and then the SP is the phantom scatter factor. So that it takes question 1, question 2. The purpose is that we need to determine how the different sizes of field size affects our dosimetry and the secondary particles that are created and our output. That is why it matters. So now show the relationship between the total scatter factor and field size. Best way to do this is really you draw a graph. That's my go-to. Draw a graph. So you're taking this output of a machine for a reference field size of 10 by 10, and you're accounting for a different field size. So that's what we're doing. Down here, we're going to have field size, and that's going to be on our x-axis. Then over here on our y-axis is going to be our SCP. And we're going to see a curve similar to this. All right, so now what happens here is that let's say at this point we have our 10 by 10. That's our reference field size. So I'm going to draw this up. And where that meets the line is our total scatter factor of 1. So again, the total scatter factor is 1 at your reference field size. So if you go above that reference field size, what we see is a slightly higher number. And if we go below that field size, we're getting a lower number, which makes some sense, right? Because smaller field size, smaller secondary particle range, and smaller amount of interactions, build up, things of that nature. So that is the total scatter factor. If you got any questions, please comment below. We have our in-error factor to talk about. We have our patient or phantom scatter factor to talk about, and we'll do those next time. Thanks a ton. Best of luck studying.